Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we're going to discuss here the creating a toolpath in a CAN environment using Autodesk Fusion 360. So first of all, we'll look at this component. So here we have to first face mill, then we can do the drilling. So here we have to create a environment for drilling purpose and then here two diameters is there. So here the two diameter is having 10 mm and here the central hole is there, that is called as that is the 20 mm diameter. So first of all we create the geometry in a Fusion 360 software. So first of all we look at the that design mode. So this is design option. So first of all we create this geometry into the software. So as you know that you have to select this sketchbook or can say sketch environment. After that we move to the selection of the plane. Then we create a rectangle which is center point rectangle. So it only you have defined the center point and you have to uh, create the corners. So in that content we have to discuss here first center, then we give the dimensions over here. So first of all we give the dimension for this 110. So according to your usage you can do this, and then after pressing the tab button we enter for the 55 mm. So this is the geometry we have to finalize, and then you enter what is there. Then next we can take a finish sketch, then we extrude for this end up to 25 mm. So after this, okay, then we move for the creating a holes. So that's why again we move to the create sketch, then select this plane, then we have to pan it. So this is pan option. By clicking we can move this object at a one place. Then next we move for the creating a hole. So that is why we can create a circle over here, and that circle will be up to 20 mm. So I select here 20 mm. So as per your requirement, so actually it is 23. So I corrected it actually. So dimension is there, sketch dimension. We put this. So here over sketching is there. That's why it is not possible. But I want to 20 mm. Okay. So after that we go for the 10 mm diam. So here I would select this hole. Approximately dimensions we can select here. So two holes will be there. So at one end is to be from this end to this end. So this end to this end, this is about 40. We can take 40 mm. From this also we can take 40 mm, right? So okay. Then we go for the dimensions for this diameter. So it is about 10 mm. So as per your requirement you can give this. Then also here we can create for 10 mm. So this is for 10 mm. Now we move for the dimensions like that vertical dimensions from this point to this point. So it is up to 10 mm. So I can move for this 10 mm. Similarly for this point to this point. So this is about 10 mm. Say okay. So this is the geometry we have to create here. Then we go for finish sketch. Then we for extrude command. So we extrude for three holes. So this one, second, and third. So this is hole. We have to extrude in negative direction. So that's why I create a hole. Say okay. So this is geometry we have to prepare as per these dimensions. So first of all we go for face mill, then we go for drilling purpose. So first of all, for selecting the CAM environment, we move the manufacturing workspace, and then we have to create a machine setup. and therefore we have to go for work coordinate system. So here we are defining the z, x, y directions. So always remember that the z is a vertical manner and y is in a horizontal manner. So this is the way we have to define the coordinate system. Then we go for stock selection. So while stock selection is required, uh, we have to go for 3 mm, 4 mm for facing purpose. We can give this stock for upper side, or can say top of the side. So this is the setup box. Here we can select the setup, and here we have to define the workspace, that is work coordinate system, that is Z, WCS. And after that we go for the that stock selection. So this is the stock selection we have mentioned here, and then we go for the that way of stock selection. Okay, so first of all we move for the environment. So here design environment is there, or you can say design workplace is there. Now we move for the manufacturing workplace. So as I mentioned here, so this is manufacturing workplace, and here the number of options is available with us. That is, first is a milling, then turning, additive manufacturing, probing method for dimensioning purpose, fabrication, that is for sheet metal working, then other utilities. So this is the options we have provided over here, and the setup box is here. So as per the recommendation from this that machine we have selected, then setup, then work coordinate system and stock selection. So according to that we have to go for first setup. So here we create a new setup. So as you know that the selection machine is required, so we go for selection of machine. So here number of machines is available with us, like Acrodony lab, Acrodony 3D labs, Additive industries. So here all machines is available with us. So here we have to go for milling operations, because milling and drilling is same as that of. So here first of all we mill it and then go for drilling. So first of all we select this milling. So this is filter, and this is other informations over here. So you select this milling option, then according to our usage we can go for the operation setup. Suppose I select here this machine, or you can say any other machine. So regarding this, the number of options is available with us. So I select this machine, and here go to the this side. So here machines reference point is given to this, then maximum number of tools is 100, tool change time is about 50 seconds. So this information is will be obtained here. So this is the coolant, and as per requirement we can give this. Here edit options is there, so according to this edition we will do changes in the option, like maximum number of tools, then tool change in the timings. So like this we can select. Then we have selected here Autodesk generic 5-axis AC head to head, or can say head to table. So you have to select any one of that options. Okay, so I select here head table. So select here. After selection of this, we go to milling operations. So here setup is milling. Now we move for work coordinate system. So here select Z axis to plane, and here always remember that this is a Z axis. So select Z axis. So top of the side go to Z axis. Then stop here. We can select origin also. So I select origin at this point only. So from this end, the tool will be moved and your operations will be performed. So suppose I want this operation first, this operation second, this is third, and after that billing. So according to your usage, the tool moves from this point, that is this point, that is selected point. Suppose I want point from this end, so I go to this point, selected point. So here I select. So here the tool will be started from this end. Likewise, you can change it. Okay, so here I change only selected point over here. So as per your requirement we can change it. Then we move for the stock selection. So here relative size box is there. So here box system is there because if it is cylinder is there, you can go for cylinder. This is box because here rectangle shape is provided here. So I can select fixed size box or relative size box. This is two options. Okay, so fixed, when it is fixed means there is no any stock. So if you select relative size box, so you get the options like top side offset. So if you want offset is at the side, so this is sides, you can select, otherwise you can make a 0 according to use, you can do it. And from top of the surface I select top of the surface I want, because I do here surface finishing, so 2 mm, so it increase. So if you see it place 3 mm, so here it is increase. If you put 4 mm, so 4 mm increase. So likewise, if you changes in the stocks according to your research. So I select here 5 mm, say OK. Now we move for the first operation, that is the face mill. So face milling operation is there. So here we can remove the surface of the upper sides. So that is why first operation is face mill. Then we go for drilling, right? So first of all, we select here the 2D. Your face option is there. So you select the face option, then select the tool. So here tool library is there. Okay. So according to your usage, you can go for tool library. So here the number of options is there. So you select the milling option, then hole making, then turning, cutting, probe, holders. So likewise, you can take select options. But I want milling operation, so I select this milling. According to our usage, we can go for the flat in mill. So I want flat in mill, so that's why I can select flat in mill. And here we change the diameters also. Suppose I want change diameters according to usage, you can do here the here selection of equal. So you can take 10 mm. So according to usage, you can select and modify this tool library also. So here the number of options is available with us. So 18 mm, that 40 mm, 0 mm, corner radius, diameter is given to 8 mm, flute length is there, oral length is there, and type is there. So according to usage, you can select over here from this tool library. Otherwise, you can go for changes in the particular sizes. So if you required in a diameter size, you can vary it over here. So this is diameter size. Flute length we can modify it, then overall length also modified it, corner radius also you can modify it, and number of flutes is also can modify it. So according to your usage you can modify accordingly. Okay, now I select over here the 80 mm this tool, so I select here. Okay, then I given the link for the surface and say okay. So this is the first operation. So here only we have select the tool according to your usage. Then we move for the next, that is generate. So here you can generate the path. So here generating the path. So here the green line indicates the tool will be approaches. Okay, so the tool will be approaches, and according to the blue lines indicate the tool is in contact with the workpiece. That is why the blue lines will be indicate. And if it is the tool is go outside, so this tool is not contact with your workpiece. So that is why you can identify like this. And if your the approach, this yellow lines is indicated for the tool will be moves faster, or you can say move speed up. So this is the that for line indicates yellow lines, and the tool emerges from this point, this red indications. Okay, so tool emergence and tool left out from this end. So this is the green arrow is indicated over here. So likewise this operation is done. So action, simulate, and play for this. So this will be play for moving the cutting this tool path, and here we can move for the further operation. So that is why cutting the tools. So if you modify accordingly, this is a face mill, and here we can slow down. So if you require speed up, you can change this mode. Otherwise you can speed up like this. like this. So tool will be moved like this. Suppose you want the stock size, over here the operations will there. Transparent mode is not required, so you can write select over here. This is transparent and this is not transparent. So tool will be moved like this. If it is tool in contact with this workpiece, then the line will be blue. Okay. So likewise we can construct like this. Say closed. Okay. So this is the first operation we are done here. The next operation is drilling. So here the tool selection is already done for facing mill, and therefore we have to create this tool path with the help of these options. Now we one more additions is there. So I connect for this also. So that's why I cannot go to this tool path. If it is changed, you can do here like this. So edit option is there. Then WCS, or can say this 1.1 KB, the data will be stored for WCS. So as per your requirement, we can change the spindle speed, surface speed, cutting feed rate, then feed per tooth. Like this, we can change it according to usage. So number of paths is also there. We can remove the tolerances like this. So this approach we can do in a multiple depths, or multiple depths is also there. So if you select this, so you can take number of passes. So if you required it, then we can give the multiple depths. So this is regarding the face. Okay. Now we move for next operation, that is drilling operation. So first of all, we do the operation for this center, that is 20 mm dia. So here the drilling option is there. Drilling means we have to produce a hole, right? So here we can take a drill option, and then we can go for selection purpose. Now we have to select hole making, that is nothing but drilling operations. Okay, so this is a drilling operation. So here the number of tool path, or can say tool, is there. So I want drill operations, so that's why I can select drill. Simply drill I selected over here, and as per your requirement we can go for the drilling bit. Okay, so if you require the number of tools, so then we can scroll down, and according to your usage we can modify it here. But our system is in metric, so 0.79 inch is there. So this indicates 0.79 inch, that means it is up to 20 mm diameter, correct? So here it is 10 mm diameter. That indicates what? That indicates metric system. So this expressed in a metric system, and this system, that is 0.79, that is into inch system. So we can say that this is about the inch system, that is we can convert for 0.79 to metric system, that is converted 20 mm. So as per requirement we can select like this 2079. Okay, then select over here and select this face, that is whole face. So here also we can change. So selected same diameter as per this. Okay, then next heights, you can change height also. Number of passes, rapid out, or you can say according to your usage you can do like this. Suppose tapping is there, then you can select this. Bore milling is there, so according to your usage you can select over here. Then here spindle speed, we can vary it. Surface speed, plunge feed rate, feed per revolutions, then retract feed rate. So this is the selection criteria. As per your requirements we can vary here. So likewise we can change. Okay, so if you require this drill aluminum drilling, aluminum drilling is there, brass drilling is there, copper drilling is there. So as per requirement we can take the drilling bits, and here the according to that we can vary this speed also. Okay, so this is the operations we have to clear out. Now we are to formalizing the generate the path, say yes, and after that you can simulate. So you are simulate here like this. So here we can make a hole like this. Okay, so here transparent also is there, you can remove it. Okay, so this is the regarding the drilling operation for this bigger hole. Now we move for This is bigger hole we have created. From this tool library we have selected the tools. So this is the tool library, and you have to select this tool for drilling operations. Then next we move for the drilling width. You have to select here. Then next we go for the two small holes. Okay, so for the purpose we go for again the drilling, then drill. Again you have to select here, selecting the tool. Here the hole making is there. So diameter is 10 mm, right? The two holes is having 10 mm dia. So as per your requirements, we can go for 10 mm dia. So I consider here drill operation. So as your requirement of this drill operation is there, then 10 mm diameter is required. So here 10 mm diameter is mentioned here, and here, right? Diameter is 10 mm. Flute length is 18 mm. So this is regarding the changings. That ore length 130 mm. Type is drill. So we have select this drill. So after selecting this, you can check this path and then select. So after this, we get the tools selection. So hole selection we can consider here. Diameter is about 10 mm. Okay. So this is the tool orientation also there. We can change it. So this is the change. Say okay. So here also we can change the geometry. Default preset is there. So as per your requirements, we can change this that spindle speed, then surface speed, then plunge flow rate, then feed per revolutions, then retract feed rate. So as per your requirement, we can vary it. The coolant is fluid or air is there, suction is there. So as per your requirement, we can give this. So this is about 10 mm dia. Say okay. So this is regarding this operation. So this is drilling operation. Now we can simulate this. So first of all, you go for generate path, say yes. Then next we go for simulation purpose. Then you can simulate this. This is the simulation for this making a two holes, right? Then say close. Now we observe the same, these three operations, same that simulations. So we are select the shift button and these three operations over here. Then action, generate, yes, then action, simulate. So here simulation is there. So this is first operation, this is face operations is there. So facing operations we are doing here, then this bigger diameter hole, then this smaller middle hole is there. So this is the operations circulated over here. This is first operation, that is face mill. Then we go for the drilling operation for bigger diameter, then we go for that small drill hole. Okay, so this is the three operations we are perform in this that session. So in that session we are to generate also post process. So this is about simulation. Now we move for the post process. Post process means you have to create a tool paths, and you have to create a part programming, that is feed into the computer. So this is the regarding this. Now we move for action post process. So here we will select the different machines available with us. So as per your requirement, you can select this machine. So mostly the Fanuc system is there, that control type is there. So I select here Fanuc controller. So this is the processor, and then we have to make a post. So after the post, here we can select the desktop path, and here we select this only name, change the name 10026. So as per your requirement, you can give the name save. So after that we'll get the direct operations. So here you create this that tool path. So this tool path we have to save it, and we have to given to the that CNC machine, and then the tool will be moves and your workpiece operations will be done. So this is simple method for generating the tool path. So this is the Fusion Cam. So this software is called as Fusion Cam. So here the workpiece is the manufacturing workpiece. Here we have to create a face mill. That's why we can select this face. Then according to your requirement, we can select the tool. Then after that, we can select the spindle speed. Then that revolution speeds, okay, change here. Then we go for the drilling operations. First of all, we select this bigger size diameter. Then we move for the smaller size diameter, and after that we can simulate this. So this is regarding the that manufacturing end, that's the post process, and here we are generated the NC program. So this NC program will help for to generate, or can say to create a new job from the manufacturing end. So this is the path generation method. So here turning operation is there. We can turn the different operations. Additive manufacturing is there, probing method is there, fabrication is there, then utility is there. So this is the method we have to say there. So meaning operation is there. As per your requirement, we can give this tool path as well as this method. And now we go for the this series. So this is the, if you require changes, so I can double click it, and then we move for the selection purpose. So if you edit it, you can directly click on these tools. Suppose your selection of tool is there, so you can select this and then select OK. So likewise you can edit also. So this is the regarding the software for generating the tool path. So again we can simulate this. So I select first this tool, then second, then third, and then say use simulate. So first operation, that is face mill. After that, bigger diameter drilling is there, then smaller size drilling is there. So this is regarding the cam generation path. Thank you.